Good morning again, and thank you for joining us today as we talk about safety laser scanners. My name is Lisa Shaw, and I'll be your moderator. I work on the marketing team here at SICK, and I'm excited to be hosting today's session. I'm also pleased to introduce today's speaker, Tyler Glieden. He is a market product manager for industrial safety products at SICK, and he is an expert in safety lidar technology for various applications, including mobile robot navigation and industrial machinery safety. In this webinar, Tyler will discuss SICK tools and products that identify and resolve false trips, as well as other errors that may cause unwanted downtime. Before we get started, I want to share that a recording of this webinar will be sent to you following today's presentation. Also, feel free to ask questions at any time during today's event by typing your questions into the Q&A box, which is located on the right-hand side of your screen. We'll take some time at the end of today's presentation to address as many questions as time allows. Lastly, we will be asking 2 poll questions during today's session, and you can answer those near the Q&A box on the right-hand side of your screen, and it will pop up when the poll questions are live. Now I want to turn our time over to our presenter, Tyler. Tyler, please take it away.
Thank you, Lisa. So thank you for joining everybody this morning for the webinar on troubleshooting and diagnostics for safety laser scanners. So I'm going to give a brief overview of SICK's safety laser scanner portfolio, just so everybody is kind of aware of what we offer from a safety laser scanner perspective. And then we will talk about dealing with errors on safety laser scanners. What are the best ways to address those errors and find out what's going on? And then the real bulk of the webinar will be spent on ways to identify and resolve false trips. And then we'll round it out with a Q&A session. So from a SICK safety laser scanner portfolio point of view, I want to start off on the history of safety laser scanners at SICK. So actually back in 1994, SICK invented the very first safety scanner based on 2D LiDAR technology. So SICK actually invented the very first safety light curtain back in the early 1950s. And then some 40 or so years later invented the very first safety laser scanner based on LiDAR. So a bit of interesting trivia there. The PLS was in operation, well, actually is still in operation today in quite a few plants. You'd be surprised. But about 9 years later, SICK came out with the next iteration of their safety laser scanner with the S3000. And then just a short 3 years later, launched the S300, which is the smaller form factor between the two. And then as you can see through the years, there have been more and more iterations. The next big breakthrough really came in 2016 with the introduction of the Microscan 3. Since then, we've launched more and more variants of the Microscan 3. The Outdoor Scan 3, which is the world's very first and currently only safety laser scanner that is rated for outdoor use. And then the most recent launch has been the NanoScan 3. So this is the lowest profile safety laser scanner on the market. So as you can see through the years, we've had lots and lots of new innovations in the world of safety laser scanners. And so we do still offer the S3000 and the S300 platforms today. There's no plans to discontinue them at this point. But I do want to bring most focus to the Microscan 3, the Outdoor Scan 3, and the NanoScan 3, as these are the latest safety laser scanners and the ones using our most up-to-date scanning technology, which I'll talk a little bit about on the next slide. But really, this is a very comprehensive portfolio that covers pretty much any application that calls for a safety laser scanner. So with the Microscan 3, we certainly have our highest performance product. We have a long range of 9 meters, which is the longest on the market, as well as options for safe networking with Ethernet IP SIP safety, Profinet ProfiSafe, and the SICK proprietary safe network protocol of FE Pro, which is based off of Ethernet IP SIP safety. As I mentioned, Outdoor Scan 3 is the first of its kind and currently only of its kind, being the only safety laser scanner rated for outdoor use. And then with the NanoScan 3, just the all-around best in class. So I see the NanoScan 3 being the safety laser scanner that will be looked at first in most applications, just due to the small size and high performance. So with that, I'd like to bring up our first poll question, just kind of interesting for me to know, for everybody that's on. Lisa, if you could pull that up. Thank you. So I'm just curious if everybody that's on the webinar so far, if you are familiar with or have used SICK safety laser scanners. So our older generations with the PLS and S300, S3000 series, the Microscan, Outdoor Scan, or NanoScan, maybe it's both, or maybe you do not yet have any experience with them. All right, I'll give you a little bit more time to answer that before I move on to the next slide. So one thing that all three of those scanners have in common is their scanning principle. So the Microscan, Outdoor Scan, and NanoScan all use the Safe HDDM scanning technology. That stands for Safe High Definition Distance Measurement. So in the past, with scanners like the S300 and S3000, really just the general scanning technology for most safety scanners that you see out there today, take 500 data pulses per rotation of the laser. So that laser spins around, depending on the type of scanner, usually between 30 and 40, every 30 and 40 milliseconds. And so again, with those scanners, they take that 500 data pulses. Well, with Safe HDDM, we've increased that to be more than 80,000 pulses per scan. So increased by just a little bit there. It does give you a whole lot more data, but it's not just the fact that we're taking more data. There's a lot of smart algorithms built into the scanner to be able to say, what I'm seeing is either ambient light, it's light or a signal from another optical device, it's dust, it's dirt, it's something that I shouldn't care about. It's something that we should ignore. It's not an object or a person that we want to cause the safe outputs to go low. So we're really able to much more easily filter those things out to reduce false trips. And as I said, that's a big part of today's topic, is identifying and reducing or eliminating false trips. And so right off the bat, I want to make it clear that SICK has done everything possible and has done a very good job to try to eliminate those inherently from the get-go by using very highly technological scanning principle. So ambient light is something that we really see is not a problem at all with these scanners. The dazzling error is more or less eliminated completely. So we're able to deal with up to 40,000 lux of light. The scanner standards say that you need to withstand up to somewhere around 2,000 lux of light. So we're actually 20 times better than that. That's part of what enabled us to create an outdoor rated safety laser scanner, because typically scanners can't deal with the sun all that well. But due to that scanning principle, we actually deal with that very, very well. But we also are able to filter out things like dust and dirt, both falling through the air and accumulating on the screen. Very, very robust performance against those things. So the first thing I want to talk about is dealing with errors. What do you do when your scanner is in a down situation? Maybe it's giving you some sort of code, the screen is red, you're not really sure what's going on. So the first thing I would suggest to do is check the display. With those three variants that I mentioned, all of them have a bright multicolor clear text display. When everything is good and running, it's very easy to tell. Let me grab my laser pointer here. You will have this big green check that's right on the face of the device. So that's quite easy to determine. And then if someone is in the protective field, you're going to get this big red X telling you that, hey, I'm seeing something in the protective field, my safe outputs are low. Now, there are many other screens that go along with this too, one of them being the contamination warning. So it's yellow being the warning, saying that my outputs are still high, everything's good, but I'm seeing some accumulation of dust and dirt on the screen, and I think it's a good idea to clean it. Otherwise, if we get any more dirty, then we're going to have to go into a contamination error and the safe outputs will go low. So we're actually going to tell you that before it affects any machine uptime or productivity to clean that screen before it gets to that point. Now, there's a combination of these graphics as well as nice, clear text to tell you what's going on. So if this isn't clear enough for you, that telling you that you should clean the screen, you can use the arrows, the push buttons that are directly on the device to navigate that menu. On the next screen will tell you optics cover is contaminated, clean it. So again, if those graphics aren't clear enough, we do include that text display as well to explain what's going on. And then there are also very visible LEDs for status information that you can see from any side. So there are these LEDs that are on top of the collar of the device that actually reflect off the screen so you can see them from anywhere, not just the front of the device. So once we've checked the display, and if things aren't clear enough then what's going on, I would always recommend referencing the operating instructions. So you can pull up the operating instructions for any of our safety laser scanners, and there is always a troubleshooting section that will take you through what do the different diagnostic LEDs mean, what do the status LEDs mean, what are the different fault display, what do those things mean, and how do I rectify that situation. So this is one section in that troubleshooting part of the operating instructions that will tell you what all those different displays on that multicolor text display is and what they mean. So for instance, here we have a fault that's listed. We have the contamination warning and the contamination error. Then once you, if it is a fault that you have or an error of some sort that has, you know, a letter and a number or a string of letters and numbers, we do tell you what those different faults are in the operating instructions and what they mean. So for instance, an E1 error would mean you have a fault in the safety laser scanner itself. Typically, we ask you to do a device restart using the display or safety designer. You can do it either way, or just power down and power up. And if that does not clear that error, then generally you're needing to replace that safety laser scanner. And E1 is not a great error to get. And E2 similarly you need to do a power cycle. And if that doesn't clear it, then it's an issue in your system plug. There are a whole bevy of other errors that aren't quite as dire, things like cross circuit, short circuit of the OSSDs. And then that would tell you to check the wiring and make sure that one, there's no wiring errors, and two, that there haven't been any damage to the cables or anything done within the cabinet to create that wiring, the wiring error. Another step you can take is to use the Safety Designer software, and this is the program that is used to configure all of our newest scanners, the microscan, the outdoor scan, the nano scan. We actually can do configuration of our FlexiSoft safety controller with this now as well. So this is kind of our software platform of the future for safety. If anybody out there is familiar with SOPIS, it has a very similar look and feel to SOPIS. It was based off of that software. So within Safety Designer, oh, and I should mention, so this is free to download from our website as well. So if you go to sickusa.com and type in Safety Designer, there's just a free download on the website. We don't ask you to register. We don't ask for any information. It's just a really easy click to download and then install on your PC or laptop. And so within the Safety Designer, there's kind of a menu tree here along the left side. Under Diagnostics, you have message history. So this will give you all of the message history, including just bits of information, errors, warnings. What you can't see that's off of the screenshot over here are different filters. So if you just want to see the errors, you can remove this information of monitoring case switching. This was connected to my demo unit, so I was playing around and changing cases on it. But you can filter those things out and remove the bits of information you don't want to see in the message history. Now, if you were to ever need to contact technical help at SICK because you're not sure what's going on with the scanner, you have an error that you can't clear, this is typically where we would send you to, you can save this or print it out and save it as a PDF, and it will give us a very comprehensive list of the errors and warning messages along with the longer fault codes that we can use to dig a little bit deeper and figure out what's going on with your scanner. So that's a good point to make there, is that this message history and saving it as a PDF is typically what we would ask you to provide if you ever need additional help from our technical help group. And so as I just mentioned, one option then is also to contact SICK for help. So you can email our techhelp@sick.com. That gets you to our Tier 1 technical support, or you can call our main office at 1-800-325-7425, and then I believe there's a prompt that will get you to the tech help group. We also have safety application engineers that are positioned all around the country. I believe we have 6 of them right now. Always looking to add more to get more coverage, but we do have 6 of them strategically placed around the country. They're out there doing a lot of pre-sales support, but also post-sales. So doing this kind of troubleshooting and diagnostic type help. So this is, that's a free service that we offer, you know, in cases that are really, really tough. We want to have those guys out there to make everybody's experience, you know, as smooth as possible. Now, of course, there are some times where things go beyond what they're capable of doing, because they're not able to go out and change your configuration for you, or make changes to the mounting of the scanner, or make wiring changes. So that's a liability thing. We can't have those people going out there and doing those things, but they can offer their insight and their help as to what's going on in your application and make some recommendations. If it gets past that point where we need people to actually come out and physically do work, that's where we would get our services involved. So we do have a very comprehensive services group and a lot of different services that we offer. In addition to being able to come out and do those kinds of things, we also offer education services. We have 2 different safety laser scanner programs, education programs. One is for configuration training, which does actually take you through troubleshooting as well, but it's all based around working with your laptop and the scanner. So I think this is about a 4-hour course that you can purchase. You know, we bring the scanners, and then you just supply the laptops, and there's some hands-on training that you get for doing configuration and troubleshooting. There is a maintenance program that we offer as well, which has no laptops. So if you're interested in training your maintenance people that don't have laptops on how to do troubleshooting and diagnostics of a scanner without a laptop, we offer that as a course as well. So if that's something you would be interested in, I would just ask that you work with your local SICK representative or distributor on getting a quote for any of those services. All right, so now for the real interesting stuff, identifying and resolving false trips. So this is probably one of the main issues that people have with any optical type sensor, whether it be safety light curtains, or safety laser scanners, or even single beam sensors, is having to deal with false trips. The first thing that I want to talk to you about is our event history tool that you can find in that Safety Designer software that I just mentioned. So all micro scans, outdoor scans, and nano scans save the last 150 events in the scanner that caused the safe outputs to go low. So that could be an error, that could be a trip because something was seen in the protective field, or it could be a contamination error that caused the safe outputs to go low. Those things, up to 150 events, would be saved in the scanner, and it's first in, first out. So if you have more than 150 events, it's just kicking out the oldest events in its memory and then storing those newest events. And that just keeps happening internal to the scanner. You do not have to be connected to the scanner for those things to be saved. That's just always automatically saved in the scanner itself. So that's nice because at any point you can connect to your scanner and then upload those events that are saved in the scanner and see what's going on. Another very, very cool thing is the measurement data is actually saved for the last 30 events, and I'll show you how that works in the software. We also have event classification where we, based on the data that we're seeing, we can classify it as an object, a particle in the field, something like dust or dirt, or contamination error. There's a timestamp of all the events, so you know exactly when those things happened. And then there's also multiple sampling optimization, which I will explain in more detail in the software. All right, so with that, I'm going to jump over to Safety Designer. So this is the Safety Designer software that I mentioned. So when you connect to a scanner and open this up, the first thing you're going to see is this overview page. There's obviously all these configuration options. We're going to focus on the diagnostics right now. So you have three options under diagnostics: a data recorder, which is very useful for getting very, very detailed feedback from the scanner as far as what the scanner is seeing and what all the different signals are doing, both inputs to the scanner and outputs from the scanner. You can set a trigger in order to trigger that data recorder to start, but it does require you to have a laptop connected to the scanner while that recording is happening. That is why I'm focusing on the event history, because you do not have to have a laptop connected until you want to pull that data out. So you can imagine that I've been connected to the scanner. I would read from the device, so there's the button here, read from the device, and then it would pull in all of these trips. So as I mentioned, we have up to the last 150 events available to us, and 30 of them have scan data. So we have a total of 26 events that we're able to look at. So all of them are going to have the scan data available to us. Now, in order to see the details on each of these trips, we can either select them from the drop-down, or you can simply click on them. So if I zoom out a little bit here on the right side, so the left side is going to show us all the trips. The right side is going to show us the scan data from that trip. So if I zoom out a little bit, and then I click through the scans that I have available, it's very clear to me that this was a valid object that moved into the field. Now, there are other instances where things just all of a sudden appear in the field. So in this case, you can see, we see objects around here. It looks like there might be something small there that's small enough not to be triggered by the scanner. So again, the scanners do have different resolution settings. So that object must be under what the resolution setting is. But all of a sudden, from one scan to the next, this object just appears. That would tell me that something came from above or from below and just appeared in the middle of the field. Now, based on the data and that staying in the field for a few scans, that likely wasn't something that fell in the field. Somebody probably just stuck their hand down into the field. It's very easy to tell when this was dust or dirt that fell through the field, as you'll see a bunch of particles just show up in the middle of nowhere and then all of a sudden disappear, or dance around in the field for a few scans and then disappear. So very easy to differentiate between what these different trips are being caused by. We have the event table, which gives us a list of all of the trips that have happened. And again, we have our timestamp with the dates. That is also available over here. That timestamp and the date shows up down here at the bottom left of that portion. We have the duration, which is the number of successive scans. So all of these that have a low number tell me that we didn't scan that object for very many times. So it's potentially increasing the multiple sampling rate could help us reduce false trips because we have a lot here that are under 4. And then you have a whole bunch of other information, what case number you were in, the cutoff path, so which safe output was triggered, what field set were we in at the time, which field was infringed. We have that classification that I mentioned, so we have objects and then things that are close to the field edge or a particle in the field. We got our angle and our distance as well as some other data. So very good comprehensive data as far as the trips that the scanner's been seeing. Now the last tab I want to point out is multiple sampling. And I'll explain what multiple sampling is because maybe not everybody understands that term. So the default multiple sampling setting on a scanner, I'll go over to the configuration to show this, is 2 times. Multiple sampling is how many times the scanner needs to successively scan and see an object before it triggers the dropping of that safe output. Default is always 2, and that's the minimum. You can set that all the way up to 16 times. Now 16 times is going to reduce your false trips the most because we need to see an object 16 times in a row before we say, yep, that's a valid object, and we're going to drop out the safe output. But what you'll notice is the response time changes. Because we're needing to spend more time scanning that object, the response time is going to change here. So 650 milliseconds for a 16 times multiple sampling, but on 2, it's only 90 milliseconds. So that has to be taken into account when changing your multiple sampling rate. Now, this multiple sampling tab in the event history, this is really, really interesting because this actually tells you, so if you look at the graph here, so we have number of field interruptions. So that's our y-axis here, and our x-axis is showing us the how many scans, the number of successive scans it took, and how many interruptions there were at that many scans. So at 16 scans, you can see there's a small amount, a slightly larger amount, but still small for 14. Where we're really seeing the bulk of the trips is at 2 scans, 3 scans, and even 4 scans. So actually, if I zoom in here, we'll get a little bit better idea. So here it looks like there are about 13 trips that were 2 scans, 7 that were 3, and 4 that were 4. So 24 trips were between 2 and 4 scans. Now, if I click this accumulated values, it will actually show me the accumulation going, working back this way from 16 to 2. So you can see there's 1 at 16, but 0 at 15. So the gray bar just shows the same amount as what we had at 16. And so those just stack on each other until we get to this 2. So if you look, we had between 30 and 40 total, but it really drops down when you go to this 4 or this 5. So that tells us that, yes, the bulk of our trips are right here at 2, 3, and 4. So if I went back here and I set my multiple sampling rate to 5, again, taking into account my response time change, I would have eliminated these trips right here. So I would have went from having between 30 and 40 trips down to having, looks like about 9 trips. So that's a big change. So this is a really useful tool. The way I would recommend to use this tool is in a new application is to have the scanner running for a week or some days. Take a look at this page, pull the information from the scanner, and then use this to optimize your multiple sampling settings. Conversely, there's also the other situation where somebody could have their multiple sampling set at 6 or something higher, and then notice that they're not getting any trips. Or what would have been trips. They're not getting scans of objects at 2, 3, 4, or 5. So then you could reduce your multiple sampling rate, knowing that it's not going to increase your number of false trips, but it's going to reduce your response time and potentially be able to shorten your protective field and open up some floor space. So this could be used to help you determine that you need to either increase your multiple sampling, or you could also potentially find out that you can decrease your multiple sampling rate. All right, so I'm going to jump back into the presentation now. So that's it on the event history tool. Now we're going to talk a little bit about our visualization and diagnostics tool. So the visualization and diagnostics tool is a software program, not so much a software, but it's more just a file that can be used to pull data out of our Ethernet connected scanners and to visualize that in a very easy to read and visually appealing manner. So as I mentioned, it works with our Ethernet connected scanners. So it'd be the Microscan 3 Profinet Ethernet IP or FE Pro, our Outdoor Scan 3 Ethernet IP, or any of our NanoScan 3s that you purchase with an Ethernet capable system plug. Both our Core and Pro versions are available with that Ethernet connection. So you can see here when you connect to these scanners via Ethernet and run this tool, again, it's just an executable file that when you are connected to the scanner and you have this this file either loaded on your Windows-based HMI or Windows-based PC. So again, this works with Windows operating systems only at the moment. When you run that file, it will automatically open this window and pull out the information from the scanner. So a couple things that you'll see here. Obviously, we see the measurement data overlaid with the field data. So that's the minimum that you would expect out of a visualization tool like this, is being able to see what the scanner sees and being able to see what your fields are. But you're also going to see exactly what the screen on the scanner is showing. So earlier in the presentation, when I said the first thing I want you to do is look at the display of the device, well, if you're using this tool, you wouldn't have to go to the device itself. You'd actually get this display directly on the diagnostic tool that's maybe on your HMI or on your PC that is either in a maintenance manager's office, or really any office that's connected to the network that the scanners are connected to. You're also going to see your contamination information here, and I'm actually going to zoom in here to see it a little bit better. This kind of partial circle here, you can imagine this being the screen of the scanner. So we're looking at the scanner from above, and the scanner is looking out this way. So we're actually going to tell you what percentage contamination there is and where that contamination is happening. So because this yellow space right here, I know that front corner of the scanner is at 40% contamination, and the rest, because we're showing green all here, is pretty good. So if I need to clean my screen, I'm going to want to clean it primarily right in that quadrant right there. Now, if we had really, really bad contamination, this would go all the way to red, and again, would show you exactly where on the screen that contamination is happening. So it's a very useful tool. Then if there are any faults, again, that will show up here. And actually, I think this is shown on the next screen, so I'll go to the next one. When the fields are infringed, you will actually see which fields are infringed. It'll give you a list here. So there, my field 3 was infringed, my warning field is infringed, but I had a second protective field that I had set up that was still clear. That one is the close one that was cut off right there. And actually that shows that here too. So because I have this 1 and this X, that's telling me I have 2 different protective fields that are using 2 different outputs. One of them is infringed and the other one is not. We also have an information tab that gives you information about the scanner itself. So if you put a name into Safety Designer to call it something, that would show up here. You get the type code, the serial numbers of the scan head and the system plug. You have checksum information. A whole lot of useful info here that can very quickly and easily be accessed. And then lastly, we have an event history. So just like I showed you in Safety Designer, we have a similar feature in this visualization and diagnostics tool that will save the last 100 or so events and give you scan data. I believe in this tool, it's for the last 10 trips. So as you can click through and choose these different trips that give you, again, the timestamp, the date, the distance and the angle, and give you a graphical representation here of where those happened. If you choose one of them that has scan data available, this bar here will move along and you will see the scan data change based on what the scanner saw. And so here's just a general example of how that would look. So here we're showing our what is likely to be our Microscan 3 Profinet connected with a PLC that's able to have that Profi-safe communication. And then you can imagine in your application, you also have this HMI that is connected to the network. And this being an HMI that is Windows operating system based, you can load that file on here and just open it up and automatically see that program, which I just went through on your HMI. And then the last thing I want to talk to you about is the event cam. So this is an industrial camera that SICK sells that we came out with. It was either last year or the year before. That can be used for a bevy of things. So this is not a one-trick pony. There's a lot that can be done with this event cam, and that's something I want to make clear during this presentation. This can be used for automation, safety, identification and tracing, as well as quality. So if we're talking about our automation processes, this is something that can be set up, one or multiple cameras in an automation process and do event tracking. So you can set it up looking at certain parts of your process, and you would just send a trigger to the camera to begin either recording video or to take a picture, and then you can then start to identify what are these parts in our process that maybe need some attention. That would go along with the process optimization piece as well. Also for machine setup, so when you are first deploying a machine, maybe your efficiency isn't so high because, again, it's a brand new machine. Some things need to be tweaked. The event cam can be very useful in that case as well. And then the big topic of the day is easy diagnosis of protective field infringements or false trips. So this can be used in applications where safety is causing downtime, and you can use this to identify what's happening in those cases. And then also could be used for quality documentation as well. So it's a very useful tool for your toolbox. I would never say, hey, you're buying 10 scanners, get 10 of these cameras. No, I'd say get one of these cameras and then hang on to it and use it for all these different pieces in your plant. If you ever need process optimization, or you're having false trips of safety, or you're having quality issues, this is something that can very easily be set up for all these different situations and help you gain efficiencies and reduce downtime and do all these different great things. And so here's one. I want to give two examples of the event cam being used. First one being for quality and process control. So we're looking at a situation where, again, this is machine startup phase. It's a brand new machine. The productivity is pretty low at the moment. We're not very high with the efficiency and throughput we're seeing out of this machine. So we can set up the event cam, place it where it's needed, and then identify the areas of interest in the process. And then once we've identified those areas, and we know what's going on because the event cam captured that, we can address that. And then after that's done, then we see that the machine is now working. We have high productivity, high throughput for many, many years. And then all of a sudden, one day, our production drops. We no longer have that high productivity. So again, we can introduce the event cam, identify those areas of interest and areas of need, address those things, and then get the machine back up and running to the level that we want it to be. And then the last example is, of course, diagnosing scanner trips, the topic of the day. So we'll say we have a robot cell or multiple robot cells where we're seeing some issues. So you could do this in multiple ways. If the camera, because this is a very high quality camera that can see pretty far and in high detail, you could use one camera to look at multiple different cells if they're close enough to each other. And you could actually send a trigger from each scanner, or it could be from the PLC that's connected to the scanner, to trigger a recording or pictures from the event cam so that you could see what's going on in those different applications. Or if it's, there's not a lot of line of sight, you could use multiple cameras in one application, sending a trigger from the scanner to both cameras to get different angles at it to see what's going on. So in this example, machine is working fine, many, many years. We have a robot, it's been great for us, a lot of high productivity. And then all of a sudden, we're noticing a lot of downtime, and it's due to the scanner. The scanner's being tripped out. We're not really sure why. First thing I would suggest to do is use the event history tool in Safety Designer. Best case scenario, you're able to identify what's going on just by using the event history tool. Worst case scenario, the event history tool points you to where the problem area is. We see all these false trips are happening at a certain time of day. They're happening in a certain spot in the scan field. So we can set up a camera to look in that area. And in this example, we can see that there's actually a toy mouse that has been running back and forth and somehow getting into the field of view of the camera. So then we can set out a humane toy trap for a toy mouse and catch it, and then release it back into its toy box. And then the issue's resolved, the machine's working fine for many, many more years, and we're all happy. And of course, the event camera goes back into our toolbox to be used for another day. So kind of in summation here, SICK has many tools to help keep your machine running and productivity high. These are just a few of those things. I think a few of the things that I like to focus most on, especially for doing troubleshooting and diagnostics of safety scanners. So we talked about the event history tool and Safety Designer. This would usually be my first place I would go when trying to resolve false trips. Of course, we have the new visualization and diagnostics tool that can help and aid in that situation. So you're not having to connect to the scanner each individual time to see what the scanner is seeing. This is something that could be displayed on an HMI, or it's something that you could just have on a maintenance person's laptop where they can easily connect into the network and then just very, very quickly pull up both the live view and the event history of the scanner. So this is something that could be used constantly to always visualize, or it's something that could be used intermittently just to quickly and easily pull up scanner information without having to go through the process of pulling up the software, connecting over USB to the scanner, connecting to the scanner, identifying and opening up all those different screens. This could also be a nice way of giving somebody access to the event history and the live view of the scanner without giving them access to configuring the scanner. So you might not want somebody going in and messing with the configuration, but you just want to give them this diagnostic tool. If you are interested in that, so actually this is a good time to note, this is actually a free tool. This isn't something we're selling. This is something we developed and we are offering for free. And if you want that, you can work with your local distributor or your local SICK rep to get a hold of that. Just knowing that it works with Windows-based HMIs and PCs, does not work with Windows CE, as that is a bit different animal in the operating system world. And then lastly, we talked about the event cam. So I would say this is kind of a last resort type of thing that's used when you have a really stubborn situation that you just can't figure out what's going on. But again, it's a really, really nice tool to have in your toolbox for a multitude of different situations. All right, with that, I would then ask Lisa to pull up our last poll question. All right, so out of these three tools, which ones do you think would be most useful for you or your company in identifying and resolving false trips? Event history tool, visualization and diagnostics tool, the event cam, or do you think a combination of two or potentially all three of them would be the best choice for your own use or your company's use? And then while you are finishing that poll question, now is the time when I will open it up to questions.
Thank you very much, Tyler. Appreciate the presentation you gave there. Wow, I learned a ton. I don't know about the rest of you. This is, by the way, this is Brian Sellers. I'm also part of the marketing team here at SICK, and I will be leading the question and answer session. So got a bunch of great questions here, and we'll try to get through just as many as we can here in the time allowed. And I hope everyone can stay patient with me. I will try to get to your question if you submitted one. Got a good one here about the S3000 models. Is safe HDDM in use on current S3000 models? And I think I can answer that, Tyler. Isn't the answer no there?
Sorry, can you repeat the question?
Yeah, sure. It's safe HDDM. Is it in use on current S3000 models?
Yeah, so the answer is no on that. So the S3000 and S300 series scanners use the conventional scanning technology. Now, I will say they do perform still very, very well when it comes to not being affected by dust and dirt and ambient light when compared to other scanners on the market. So we have done some studies on this. But the newer scanners with the safe HDDM are literally off the chart in performance when it comes to ignoring those false trips.
Excellent, excellent. Here's another one talking about the error codes. Are those error codes that the scanners send out, are those sent out over Ethernet IP?
Yep, you can. So that's a good point. So that's something that I wanted to bring up but forgot. So when I say you can, when the scanner has an error, you go to the display or use the software or use the visualization and diagnostics tool to get the error code. That can also be communicated out over Ethernet, whether you have Microscan 3 Profinet, Ethernet IP, FE Pro, or one of the nanoscans that has Ethernet. You can get all of that diagnostic information out over the network.
And the color text display, the error codes that we give out on that, those are also, I mean, that's what we're talking about here, right? Those are the errors that are sent out, the error codes that are sent out over Ethernet.
Yep, exactly.
Yep. Okay. Yeah, perfect. Now, this one person is asking if they could get to an AGV traffic management system, and I'm assuming not the AGV controller itself, but to the traffic management system. And I guess as long as there's a way to for the AGV itself to communicate to that traffic management system, we should be able to get those error codes back all the way there, shouldn't we?
Yep, exactly right. So as long as, I see there would probably be multiple ways to do this. But yes, as long as the AGV, whatever controller on the AGV has access to that traffic management system, you could absolutely pass along that information.
Yeah, perfect. Now, remember in the presentation you mentioned that the scanners can hold the last 150 events. If the scanner's powered down, are they still saved?
If the scanners, oh, no, okay, yeah, I see. Yep, so those are purged on a power cycle. So yes, it will save the last 150 events as long as the scanner is continuously running. But as soon as you power it down, all of those events are lost. Part of that has to do with the time stamping. So the scanner can't keep track of time while it's off. It kind of loses that. So as the scanner's powered on, it remembers how long it's been since it was powered on, and then when you connect to it with a laptop, it kind of cross-references that with the time of the laptop to get the timestamps.
Gotcha. Perfect. Okay. And is that history, can it be sent out? Can it be exported to a server before it gets overwritten?
Can that history be exported to a server? So I'm going to pull the software back up here real quick. So you'll see here that you can store the data. I would have to double check to see if that's something that we can automatically do through the data output tab, which I want to say yes, but I'm not going to say yes with 100% certainty, because the way we get this information through that visualization and diagnostics tool is we're really just doing it with the data output capabilities of those Ethernet connected scanners. So I know you can get that information out. So you would be able to log that yourself by pulling it out over Ethernet. But another way to do it would be to every so often store this data in a file by connecting. So I think you could do it either way.
Okay. All right. So is the event history itself accessible even when the rest of the configuration file is password protected?
Yes, I believe so. So I think you just have to be at the maintenance level. So there are different login levels in the scanners. There's like authorized client, which you need in order to be able to make configuration changes. There's a maintenance level. So yes, at a level where you can't configure it, you could still get the diagnostic data out of it.
Okay, perfect. Thank you. And let's say, let's get a good one here. So if we're saying, how does the scanner differentiate, but say like between screen contamination and somebody actually holding their hand or some object right up against the scanner itself?
Yeah, so there are contamination sensors that are in the collar of the device. Let me go back to the slideshow here and see if I can quickly find a slide that shows a scanner that I could easily point out. There, so right here, the flat part of that device, there's actually multiple contamination sensors that kind of look up. And so it is, if you actually take your finger and put it down over those sensors, you'll get a contamination error because it sees that that sensor is 100% covered up. So it'll give you a contamination error. So it is possible to trick it into thinking that there's contamination, but if you just put your hand in the protective field, it will never think that's contamination, because it actually, those contamination sensors are the ones that have to be blocked at least up to a certain percentage.
Okay, great. Yeah, that's a great answer. Got some questions on the event cam. Is it possible to use this to and I think I know the answer, but I'm going to let you answer it, Tyler. Like if someone's wanting to use an event cam for to take a picture at a pedestrian / manual vehicle crossing, like if you're on an AGV type of application, could that actually take a picture of that, you think?
Yeah, I don't see why not. So the event cam, all you would need to do is have some sort of trigger. So whether that be some sort of optical sensor to say when this sensor is covered, we want to begin taking a picture or a video then, or it could be a signal from a PLC, could be a signal from the AGV. It's completely open as to what you use to trigger that, but I don't see why that wouldn't work.
Yeah, cool. Okay. Here's another one about false trips and everything. Jeff asked, to prevent false positives, are these scanners filtering data points that just pop in and out of existence? Or is there another way to filter these points, like any additional settings for that kind of thing?
All right, I'm trying to unpack that a little bit. So to prevent false positives. So I don't know if this will answer the question directly, but I'm going to explain this the best I can. So with the Safe HDDM, what it's doing is, because we're taking so many more data points Actually, I'm going to scroll back here because I like to have a visual up while I explain this. Because it's so many more data points, what we're able to now do is when we're seeing, you know, if you take so when we talk about conventional scanners doing 500 data points, if you just take your hand and spread out, you know, your fingers, you can imagine if one of those fingers sees an object, then, okay, we can say, all right, that's something, regardless of if that was a very small something or a big something, that whole beam saw an object. But if you take your fingers and multiply it by 20 and you see how much higher resolution there is, well, now if one finger sees an object, but the ones immediately around it don't, we can say, okay, that is much smaller of an object than we care about, and we can kind of ignore that. It's not that we're eliminating it. We're still seeing that, but we're saying, okay, I know that's not something I care about because one out of these, you know, 500 data pulses saw that thing, or 3 of the 500 data pulses. So with all that extra data, it just makes it much easier for us to reliably determine the size of an object and the classification of an object.
Okay, perfect. Yeah, that makes sense. Let's see, we got a few more here. So let's pick one here. This is another one from Katie. So let's say you've got an AGV, an automated guided vehicle. You've got a scanner, say on the top of it, and a couple at the bottom. Can you set the sampling rates individually for each of those scanners?
Yep, absolutely. So every scanner can have its own different multiple sampling rate set. Again, I would always use the caveat that you know, you need to keep your response time in mind in combination with what your safety distance calculation is. So as you increase your multiple sampling rate, that's going to increase your response time, and that might mean you need to increase the size of your protective field, because then you're going to need to detect something out much further in order to have the correct stopping time. But all the different scanners can be individually set, and I would actually add to that to say you can have different multiple sampling rates within the same scanner. And that's something that's really, really unique and cool about SICK scanners. And I can actually show this very quickly. So if I go into the software and I set one protective field here, I can change the multiple sampling rate here to 9. Add another field. We'll do a circle over here. And that one I can have set to 16. So now actually the scanner is going to, in itself, say, all right, I need to, when I'm looking at this field, I need to see something with 9 successive scans. When I'm looking at this field, I need to see something with 16 successive scans. So you can actually have individual field settings in the same scanner at the same time, which is really, really neat.
And that would be used for what? Like if it, say one area is dirtier than the other or something like that?
Yeah, so one example I like to give, and I'll change the way I've drawn this a little bit. I'll move this over here, and I'll create a new one right here. Actually make that a little bit smaller. So let's imagine there's a machine right here, and there's a lot of dust and dirt that falls down. And this is, so let's say there's a fence here, and so the person would enter from right here, walking from right to left. And because we don't want all that dust and dirt or wood chips, whatever it might be, to cause false trips of the scanner, we would set the field that's closest to the machine to a very high multiple sampling rate. But we also don't want to affect our overall response time of somebody entering the field, right? So we could take another field that's set up to the right of this. This is where somebody would enter, and set that at a low multiple sampling. So now my response time for somebody entering the hazardous area is very, very quick. It's at 90 milliseconds. But because I have individual field settings, we're still ignoring all those wood chips that are here. And because the person's already in here and the machine's going to be stopped, it doesn't matter if they walk in here. They've already been detected. The scanner's going to stay off whether they're in this field or this field. So that's a combination of using a high multiple sampling, but with having still a fast response time by using a second field with low multiple sampling. you kind of get the best of both worlds.
Yeah, and what's the max number of fields we can have? We can program on there?
On the scanner. It depends on the scanner that you use. So with our core I/O products, you can have 4 simultaneous fields. Now with a core I/O, they're all going to control the same output because you have one OSSD pair. So if I did my monitoring case, and I know this isn't a configuration webinar, but hey, we're here, why not? I would choose both of these to control the OSSD pair. And so regardless of which field is infringed, they would control the OSSD pairs. Now, if I were using a, let's see here, I'm going to try to do this very quickly, a network connected scanner, because our Ethernet IP, our Profinet, or our FE Pro scanners, core devices can have up to four simultaneous fields, but each of them can control a different safe output. And the reason for that is it's all being done over the network. Even all the safe communication is over the network. So as I set up 4 fields, I won't actually draw them. Actually I have a Pro here so I can do 8. So with the Pros, we're able to do up to 8 simultaneously. And in our monitoring cases, we would just set different safe outputs. So these are just bits that are being communicated over the network, which is why we're able to do so many at one time. If this were an I/O device where we actually had hardwired outputs, this would be taking up 16 pins, which is crazy. But it really opens up a lot of flexibility when we're doing this over a safe network communication.
Yeah, sure. I'll tell you, this has been great, and we've got a couple other questions here, but unfortunately we are out of time. We will promise everyone that's on this webinar that we'll get those questions answered and sent out to everyone. But hey, we want to thank you for joining. Thanks for sticking a few minutes later, and I want to thank Tyler for his time and his brain this morning. Appreciate his intelligence on this, and thanks again for making this stuff make sense to even the simpletons out there such as myself. So again, thanks for joining, and we'll see you guys at our next webinar. Thanks again.
Thanks, everyone.